Have you ever wondered why astronauts, when in space, don't see the thousands of stars that twinkle brilliantly far from Earth as we do on our home planet? You might have seen those iconic images of the moon and no stars, which even led to suspicions about the authenticity of the moon landing. But rest assured, there's a simple reason for this phenomenon. Welcome to Science with Lou, the channel that explores the wonders of the universe, delves into the mysteries of science, and brings you accurate and fascinating content. In this video, we're going to unravel the mystery of why we can't see stars in space. It's a question that has baffled many and will provide a scientific explanation to satisfy your curiosity. Let's address the elephant in the room. When you look at pictures taken on the moon during the Apollo 11 mission, featuring Buzz Aldrin, Neil Armstrong, and Michael Collins, you might wonder why there are no stars in the background. The moon's atmosphere lacks clouds, haze, or any obstructions. It should be the perfect canvas for a magnificent starry sky. Yet, these images, among the most famous in spaceflight history, show a pitch-black sky with no stars. This absence of stars has led some to question the legitimacy of the moon landing, speculating that it was staged in a Hollywood studio. However, this is far from the truth. Astronauts like Neil Armstrong explicitly mentioned that they saw no stars in space. As Armstrong himself stated, the sky is deep black when viewed from the moon, just as it is when viewed from cislunar space, the space between the Earth and the moon. The Earth is the only visible object other than the sun. So, why do we not see stars in these photos and videos? The answer lies in the principles of photography. Whether it's the cameras used during the Apollo missions or modern equipment, they all rely on aperture, shutter speed, and ISO settings, collectively known as the exposure triangle, to capture light. On the moon, where there is no atmosphere to scatter sunlight, the lighting conditions are extreme. It's incredibly bright during the day, and the reflective surfaces of the moon and astronauts' suits add to the brightness. The lunar surface is blanketed with a layer of fine dust known as regolith. Within this regolith, minerals such as plagioclase and anorthosite are present, boasting high reflectivity properties that aid in scattering light. This results in a remarkable reflection of up to 12% of sunlight from the lunar landscape. The aperture controls the amount of light that hits the camera sensor. In high brightness, like the moon's surface reflecting sunlight, it needs to be reduced to avoid overexposure. The shutter speed determines how long the sensor is exposed, and too much exposure causes bright objects to overexpose and stars to blur due to motion. The ISO value affects the sensor's light sensitivity, but a high value in a brightly lit environment can create noise in the image. The result? Faint objects like stars disappear in the background. Even professional photographers, which astronauts generally are not, would need to employ sophisticated techniques to capture both the moon's surface and the stars effectively. The idea of a professional photography team in space using shaders and lights to shoot lunar images might sound quaint, but who knows what the future holds, especially with lunar colonization projects on the horizon? However, the explanation doesn't end here. The lack of stars isn't limited to photographs and videos. Astronauts like Bruce McCandless II, who flew alone in space in 1984 using the Manned Maneuvering Unit, captured iconic images, but even in these videos, there are no stars to be seen. This phenomenon is puzzling because modern video technology should theoretically be able to capture stars in all their glory. The reason we don't see stars in these visuals is not evidence of manipulation or fraud, but rather due to the unique lighting conditions in space. When astronauts are on the brightly lit side of the moon or bathed in the artificial light of the International Space Station, their pupils contract in response to the intense light. This adjustment lets in less light from the distant stars, making them virtually invisible. Yet, there are moments when the beauty of the starry sky reveals itself even to space travelers. In the shadow of the lunar lander on the moon, when astronauts step into the shade of a large rock or other object, their eyes gradually adjust to the darkness. It's at these moments that the starry sky starts to emerge, and they can witness the infinite beauty of the universe. Neil Armstrong had this experience, and astronauts on the ISS experience it when the space station enters the Earth's umbra. You don't need to travel to space to experience the fascinating effects of light and darkness. You can try a simple experiment at home to understand how our eyes adapt to different lighting conditions. In a dark room, let your eyes adjust to the darkness for a few minutes. You'll notice that as your pupils dilate, you can make out more details in the room. Then, shine your phone's flashlight or screen directly into your eyes. Your pupils will constrict in response to the bright light, plunging the rest of the room into darkness. This experiment vividly demonstrates how our eyes regulate light intake depending on the lighting conditions. The astronauts' experience in space is similar. Surrounded by the bright surface of the moon or the artificial lights on the ISS, their eyes are naturally adjusted to the intense light, making it difficult to see stars. It's a fascinating quirk of human perception and a simple explanation for why astronauts don't see stars in space. But why does space itself appear so dark and velvety, almost as if it has a texture? The explanation lies in the absence of an atmosphere to scatter light. Space lacks the typical visual cues we have on Earth, and without light scattering, it appears even denser and more impenetrable. Experts suggest that it's not just the experience of absolute darkness, but something unique that makes space feel velvety. When astronauts describe this velvety blackness, it's as though they can sense a mysterious shimmer or texture. This sensation is made possible by the absence of starlight, which would otherwise outshine this mysterious blackness. It's an experience that's hard to put into words, but it's one of the most intriguing aspects of space travel. To top it off, interstellar space isn't entirely empty. While it's much less dense than Earth's atmosphere, it's not devoid of matter. The space between stars contains a thin mixture of gas and dust, mainly hydrogen and other elements. Additionally, microscopic particles or cosmic dust particles are continually present in space, originating from various cosmic events and phenomena. One could even draw a comparison to dark matter, a mysterious and invisible substance that exerts gravitational effects in space. While it cannot be directly observed, it's distributed throughout the universe, including seemingly empty areas. As we continue to explore the mysteries of space and the wonders of the universe, it's essential to understand the science behind the phenomena that astronauts encounter. The absence of stars in their visuals is not a conspiracy or a Hollywood production. It's a result of the unique lighting conditions in space and the way our eyes adjust to bright environments. Don't forget to like this video and subscribe to Science with Lou for more captivating content on space, science, and the universe. We're here to bring you accurate, engaging, and educational content that will keep you curious and informed. Click that subscribe button and stay tuned for more stunning videos coming your way. Thank you for watching Science with Lou.